All right, here's a quick recap of everything we learned in A3 so far. So these are all of our derivative rules. So in A2, we learned about first principles, and then in A3, we learned like, oh, first principles takes forever, and there's actually these rules that somebody discovered that can get us the derivative really fast. So I'm not proving anything or going into super detail. I'm just showing you the rules really fast. Okay, so we got something called the constant rule. So that says if you have something like y equals 3, a constant is just a number on its own. So y equals 3, y equals 5, y equals negative 10, anything like that. The derivative of a constant is 0. So we proved that in a video last week, but if you are behind and you just want to know the rules real fast, derivative of any constant is always 0. Hey, what's the derivative of pi? Also 0. Okay, moving on. We got the power rule. Power rule is when you have an exponent. So if you had like y equals x to the power of 4, the power rule says that you take that exponent of 4, you put it out front as a coefficient in front of x, and you subtract 1 from your exponent. So you take the original exponent of 4, subtract 1, which gets you 3. So that is your power rule. Let's try another one. Say you had y equals x to the power of 2. Well, if you want to take the derivative, you would put that 2 out front, write down the x, subtract 1 from your exponent. So 2 minus 1 is 1, so it actually is just 2x. What if you actually just had y equals x? Well, technically it's x to the power of 1. So you'd put the 1 out front, write the x, and then the original exponent was a 1. And if we subtract 1, 1 minus 1, we would get 0. And we know that anything to the power of 0 is 1. So this derivative would actually just be 1. Also, we learned if you had a coefficient out front, so if you have a 3, like 3x to the power of 5, then all that happens is that coefficient just stays there. When you bring the 5 out front, it ends up getting multiplied by that coefficient. 5 minus 1 would be 4. So this would end up being 15x to the power of 4. So that is the power rule. It's super handy. Okay, sum and difference rule is just it's just a combo of all your rules, but if you have like an addition or subtraction. So let's say you had like x squared plus 3. The sum rule just says that we can take the derivative of each term. So the derivative of x squared would be 2x. The derivative of 3 would be nothing. So this derivative would just equal 2x. Another example, y equals 5x to the power of 4 minus 3x to the power of 2 plus x. So if we took the derivative of all of that, we just take the derivative of each term. So the derivative of 5x to the power of 4 would be 20x to the power of 3 minus 3 times 2 would be 6x, and 2 minus 1 would just give us a 1 exponent. And then plus the derivative of x is just 1. So that's the sum and difference rule. Okay, next we have product rule. A little more complicated. So product rule, so let's just say we had y equals, so we need a product. That means two things that are multiplied by each other. So let's say we had 3x times x squared minus 1. So the product rule says if you have two things multiplied by each other, so for example, we have this thing times this thing. So those are our two things. So product rule says the first thing you do when you're finding the derivative of a product is you take the derivative of this guy. So the derivative of that guy would just be 3. And then you just write the next one like normal. Then you use an addition sign. And now, for your second step, you got to find the derivative of that guy, which is just 2x. And then you just write the first guy. 3x. So that's the product rule. So it's technically written as if we call these terms like f of x and g of x, it would be like f prime x times g of x plus g prime of x times f of x. So it's saying like derivative of the first one times the second one, derivative of the second one times the first one. And then you just make it look a little nicer. Like, I might multiply these through. So 3x squared minus 3 plus 6x squared. And then collect like terms. So 9x squared minus 3. So, I'm just going to move around. Okay. So then, that's product rule. Moving on, quotient rule. So quotient rule is when you have two things divided by each other. So let's say you had f of x equals 3x divided by 2x minus, let's say 2x squared minus 5x. So quotient rule is similar to the product rule. Quotient rule says you take the derivative of the numerator, which is 3, and then just multiply it by the denominator. Now you subtract, take the derivative of the denominator, which would be 4x minus 5, and multiply it by the numerator. So it's almost the same as the product rule, but a subtraction sign in between. And then the whole thing gets divided by the denominator squared. I don't know why I did like a square bracket and a round bracket. There we go. And then I would just make it look a little nicer. Like I might multiply these through since it's just a monomial times a binomial. 6x squared minus 15x. And then this one would be 12x squared minus 15x over 2x squared minus 5x squared. And then let's multiply that negative sign through our numerator. Minus 12x squared plus 15x. 2x squared minus 5x squared. Okay, and then collect like terms. So 6x squared minus 12x squared will be negative 6x squared. And negative 15x plus 15x is gone. Divided by this guy. Okay, and I would leave it like that. So that is your quotient rule. And finally, chain rule was the last rule that we learned. And it's kind of important. You use it in combination with all the other rules pretty much. So it addresses composite functions. So if you have a function within a function. So for example, let's say we had just a simple 3x squared plus 4 to the power of 5. So this is a chain rule because technically it's a composite function. So a composite function meaning it's made up of two functions. So it's made up of an inner function, which is the one in the brackets. And the inner function we would say is 3x squared plus 4. It's also made up of an outer function. And the outer function would be g of x equals x to the power of 5. And then what happened is we did g of f of x to get the, that's what y equals. So we took the outer function g of x and we replaced the x value with f of x, that's what happened. And so to get the derivative of it, you simply take the derivative of the outer function with respect to the inner function, and then you multiply it by the derivative of the inner function. So just quickly, to get this derivative, I would totally ignore the inner function, what's inside the brackets, and I would just deal with the outer function. So I would pretend it's like an x to the power of 5. So using power rule, I bring my 5 out front. I would write my x, although in this case it's 3x squared plus 4. Subtract 1 from the exponent, so it becomes a 4. So that is the derivative of my outer function. Basically, it's the derivative of this, right? It becomes 5x to the power 4, but instead of an x, we have this whole chunk. Okay, now we times it by the derivative of the inner function, which is 6x, right? Because 3 times 2 would be 6, and then the 2 minus 1, and then 4 is nothing, so there you go. And then we just make it look a little nicer. Like, I think I might multiply the 5 and the 6x, making it 30x times 3x squared plus 4 to the power 4. So that's chain rule. It lets us find the derivative of a function within a function. And you might even have to use the chain rule in combination with other rules. So for example, let's say you had f of x is equal to x plus 1 squared times 3x minus 1 to the power 4. So this is actually a product rule because you have this times this. But the reason it's also the chain rule is because, according to the product rule, we first take the derivative of that function. In order to take the derivative of that function, you have to apply the chain rule. So let me do that. So if I'm going to take the derivative of that, it would be 2 bracket x plus 1 to the power of 1, because 2 minus 1. Then I find the derivative of the inner function, which is just 1. Then I multiply it by this guy, 3x minus 1 to the power of 4. Plus, okay, now I take the derivative of this guy. So I use chain rule, so it becomes 4 bracket 3x minus 1 to the power of 3. Then I find the derivative of the inner function, which is just 3. And then I multiply it by the first part, x plus 1 squared. Boom. So it's product rule, but I had to use the chain rule when I was finding the derivative of the individual terms. Okay, I'm just going to make this look a little nicer. So might as well combine the 2 times 1. Just make it a 2 times x plus 1 times 3x minus 1 to the power of 4. Plus, I think I'll combine the 3 and the 4 here. Make it 12. 3x minus 1 cubed times x plus 1 squared. And now what you can do is, because this form is kind of weird, it's like not factored form, not standard form. There's no way I'm expanding it because like this power of 4 here, like no thank you. But what I could do is I could common factor. So, oh man, I think I ran out of battery on my Apple Pencil. 1 sec, plugging it in, get a second charge here. So what I'm going to do is I'm going to common factor. I'm going to try to draw with my finger. So, it's not working. Sweet. I don't want to disconnect my pencil though. Okay, it's charged. Maybe. We'll see. Okay, so yes, we got this set of terms and this. So we're trying to find a common factor between those two. So if I look at them, okay, first I'm going to look at the 2 and the 12. Well, I know that 2 is divisible by both those terms. Or both those terms are divisible by 2. Sorry. And then I look at x, they both have an x plus 1, so I'll factor that out. They also both have a 3x minus 1. And I can always factor out the least amount. So this has 3 of them. This has 4 of them. So I know I can factor out 3 of them. Okay, then I'm going to go through and do my actual common factoring. So I'm looking at this. What do I have left after I've already factored out this? Okay, so I got the 2, I got the x plus 1, but I still have another 3x minus 1 bracket left because I had 4. Okay, plus now I'm going to look at this next set. So I factored in 2, but I actually had 12, so I'm going to need 6 more. Then if I'm looking at x plus 1s, I had 2 of them here, so I need another one. And the 3x minus 1s are good. Okay, now I'm almost done. I'm just going to collect like terms and simplify. So what's in the bracket will become 3x minus 1. Oh my gosh, 3x minus 1 plus 6x plus 6. If 6. And then I'm just going to collect like terms, and I am done. Okay, so 3x plus 6x, 9x. 6 minus 1, 5. Assuming I didn't make any silly calculation errors, that should be the answer. Cool. So this would be in factored form, which seems kind of handy if I wanted to graph it or, you know, do anything better than this form. Okay, so that's chain rule. So that has all of your derivative rules that we have learned so far in A3.